Hey guys, let's look at those last two questions on the related rates portion of the review sheet. So here, whenever we're doing these things, we have to come up with an equation that relates everything together, and then usually take the derivative. So if we're looking at a right triangle, we have theta, we have x, so we have opposite, and we have this hypotenuse. So if I'm looking for a way to relate theta, the opposite side of a right triangle, and the hypotenuse, the function sine. So the sine of theta is equal to opposite over hypotenuse. Let's take the derivative of both sides. The derivative of sine is cosine. The derivative of theta, d theta dt, is equal to, and then the derivative of x is 1, so we have 1/5, because the derivative of x is 1, multiply it by a fifth, so we have 1/5 dx dt. At what rate is this increasing? So we're looking for dx dt. We know that this is d theta dt, and we don't know what cosine is, but because we were told that x is equal to 4, this is the Pythagorean triple, 3, 4, 5, cosine of an angle is the adjacent over the hypotenuse. Multiply both sides by 5. 5's cancel. 3 times 2 is 6. Okay, so let's draw a picture of what's happening here. Let's see, the tank has a height of 6, and the diameter of the top is 4, so you must be 2. There's water that's leaking out of the tank, so if there's water inside here, it has a radius of r and h. And then there's water that's like leaking out, so there's some water that's coming out, and at the same time, we're pumping water in. So we're pumping water in. So if we want to express the volume of the water as a function of the height, h, from question 3, remember that the volume of a cone is 1/3 pi r squared h. Using those similar figures, we have r, h, and r, h, where the radius of this was 2, the height of this was 4, 6. So 2 over 6 is equal to r over h. R is equal to, multiply both sides by h, and 2 over 6 reduces to 1 over 3. Volume is equal to 1/3 pi r squared h, where r is h over 3. Okay, let's clean that up. Volume is equal to 1 times pi times h squared times h. So we have pi h cubed over 27. Find the rate at which water is being pumped into the tank. Okay, so we know that it's coming out at a rate of 10,000. We don't know what it's coming in at. So the overall change in volume, dV dt, is equal to, take the derivative of both sides, 3 pi h squared over 27 dH dt. The change in the volume is the, I guess we can think about it as the rate in minus the rate out. Because it's going in at a certain rate, it's coming out at a certain rate, so the overall change in volume is that in minus the out. So what is the rate in? Well, the rate in minus 10,000 is equal to 3 over 27 reduces, so we have pi and this reduces to 9. H is 2. dH dt is what we're looking for. Oh no, we know dH dt. So dH dt is 20. Okay. So our rate that it's being pumped in is equal to 4 times 20 is 80 pi over 9 plus 10,000. And then what would this be? Centimeters, I hope centimeters, yep, centimeters cubed per minute. All right, so those are those two, and then we'll do the velocity ones on the next slide.